Hello, math students. Today we are going to be working on something that is, I know, your absolute favorite. So we're going to be writing linear equations, and we are going to be doing that using story problems. Woohoo! So, what we're going to be doing today is we're going to look at some situations and we're going to be able to write an equation to represent that situation. So, this one says a car rental company charges $120 to rent a car for 3 days and 50 cents per mile. Write an equation to find the total cost. Typically, when we do this, we would write this in slope intercept form, which looks like y equals mx plus b. Sometimes they're going to give us different variables to use. So when we say the total cost, that's going to be taking the place of the y in our equation. And the m is going to be taking place, don't get confused with the slope. This is really the x in our equation. Okay. When we read these, most of the time, I'm going to be giving you two important numbers. One of them is where we start. In this case, the amount that you get charged right away is that $120. That's what we would begin by paying. And the amount that's going to change as you drive more miles, every mile costs an extra 50 cents. So that's going to be our slope. So in this case, the cost will be 50 cents for every mile. So I know that the slope is 50 cents and that's the and the m is for miles, so don't get confused there. But this should make sense. If I say 50 cents for every mile, plus we had to pay $120 just for getting the car. Now it says the charge to have a cell phone for 1 month is $59 plus 15 cents per text message. Now I know that that's not how we get charged for cell phones now, but this is how it used to be. So you get charged for every single text message. Now, I think that some parents would be broke if we had to pay for like every snap that was sent. But we want to write an equation for the cost, and X is the number of text messages. So these two numbers, the $59 and the 15 cents per text message, you pay the $59 automatically, no matter what. That's how much you start by paying. That's your y-intercept. It's kind of a weird looking B, but that's my B. The 15 cents, that's how it's changing. That's what slope is. It's always about change. And it's going to be 15 cents for every single text message. So the cost of the phone, there's my C, would be 15 cents. Whoops, sorry about that. 15 cents for, sorry about that right there. Let's see if we can delete that. 15 cents for every text message, plus the $59 that you were charged automatically just to have the phone plan. Jed has saved $120 for a new bike. He plans to save an additional 25 cents or $25, every week. Write an equation to find the total amount of money that he has saved over a certain number of weeks. So the total money that he has saved. So right now you should be thinking about which one do you start with and which one is how it's changing every week. He starts with having $120 right away. And the $25 per week, that's how it's changing. So I would have $25 every week. Whoops, sorry, my computer just went a little crazy there. And he already has $120 saved, right? So far, all we've been doing is just translating these story problems into linear equations. Now, this one's a little bit different. Ned wants to buy a car, and the car is $3,000. He plans to save $150 per week. Write an equation to find the amount of money he still needs to save after a certain number of weeks. So this time, the beginning amount that he's trying to save up for is the $3,000. He's saving $150 each week, so that's our slope. But here's the thing. The $3,000 is how much he needs. And every week when he saves that money, that's going to decrease the amount of money that he still has to save. So the money that he still has to save is decreasing by $150 every week. and it started at $3,000. Okay, so that one's a little bit weird having a negative slope on that. But again, it's because he's not like, it's not like some of the other problems where we have some money saved and we're just going to keep adding to the money that's saved. I know the total that he needs to get, so we're decreasing his total amount that he has to save each week. So here's the equation that we just used. Now we're going to actually start using these equations that we're writing. Using the equation from the previous problem, determine how much Ned still needs to save after he has saved for 14 weeks. So this is the number of weeks, right? We're going to put that in for the weeks. So the money that he still needs would be a negative 150 times 14 weeks plus the amount that he needed to start with. So negative 150 times 14, using my handy dandy calculator, is going to be a negative $2,100. When we add that to the 3,000, the money that he still needs would be $900. If I use that same equation, I want to know how many weeks it'll take so that he can get to $1,650. Maybe he's got someone who is willing to give him that much money, so he just wants to know how long it'll take to get there. Now, thinking about the equation though, I want the amount of money this time to be that $1,650. So instead of M equals, I would say 1,650 equals negative 150 W plus 3,000. Okay, so to solve this one, I would want to, now we're actually solving an equation this time, right? Not just crunching numbers. We would get rid of the 3,000, which is going to give me a negative 1,350. And then I would want to divide by that negative 150. And that would be 9. So it would be 9 weeks. Now, if I want to know, using that same equation yet, what number I would substitute in there to decide how long it's going to take for him to save all $3,000. So keep in mind what that M is really standing for. The M is how much money he still has to save. If he has all $3,000, I'm not going to put the 3,000 in there. I want the amount of money that he has left to save to be 0, right? So my equation should be 0 equals negative 150 W plus 3,000. Okay, so that's really the number that they were asking for. We could still go ahead and solve this to figure out how many weeks this is going to take. So I'll have negative 3,000 equals negative 150 W. Then when we divide, because they're both negatives, that takes care of that. That'll be a positive. And again, you can absolutely grab your handy dandy calculator, but I could also say, well, those zeros are going to cancel out. 30 divided by 15 is 2, and then there's just an extra 0. So it would take him 20 weeks if the car is still there for him. So a furnace repairman charges $85 to come to your house and repair your furnace, plus $65 per hour. Write an equation to find the total cost for working however many hours this is. So right now, I would like you to try to pause this and see if you can write the equation. Okay, thinking about what's the beginning amount and which one is how much it changes each hour, right? So this should be my beginning amount just to get to your house. That's how much he charges for every hour. So the cost would be $65 for every hour plus the fee just to get to your house. Now, if he sends a bill for $280, how many hours did he work at your house? Going back to that last one, it was C equals 65H plus 85. And this is the total cost. We're going to put that in for the C. So we'd get rid of the 85. So 280 minus 85, that's going to give us a 195. And then we're going to divide. Which would give us 3 hours. And with a label, we would have 3 hours. Now, what if, I don't know how much the total bill is, but what if I know that he worked for 2 hours? I would want to know how much I should be expecting him to charge us. So I don't know the cost right now, but I do know that the hours would be 2. So 65 times 2. And 65 times 2 would be 130 plus 85. That should be $215, I believe. Yes, $215. Okay. I've got this equation now. The equation T equals 0.05S plus 20,000 is used to determine the total earnings for a total number of dollars of sales. This is somebody who works on commission. So this part of the equation is saying that they get 5% of all of their sales. So anyone that works in sales, if you work on commission, the more you sell, the more money you get to take home, that's a good thing for someone who's a really good salesman. So if someone had $150,000 in sales, that's the S, I want to know the total amount of money that they're going to bring home. So the total money that they'll bring home would be 0.05 times that 150,000 plus the 20,000 that must be just their normal salary. So 0.05 times 150,000 is 7,500. Oops, I put that in the wrong place. Ignore that right there. So my total amount of money is going to be $27,500. Now, what if this person says, you know what? I want to be able to make $45,000. So I would need this equation that we have up here. T equals 0.05S plus 20,000. And I want to earn, the total that I want to earn is this. That's going to go in for the total. So 45,000. Now you could see from the last example, selling $150,000 worth of stuff, their total salary is only $27,500. So this is going to have to be a lot more sales. So if we get rid of the 20,000, we would have $25,000 equals 0.05S. We're going to divide by 0.05. So $25,000 divided by 0.05 gives me $500,000 is what you would have to have in sales if you wanted to make $45,000 for yourself. Okay, and I just switched my order there. Okay, so today your practice problems are going to be worksheet where we're writing linear equations. There's no learning check today, but when you're doing these problems, the problems are kind of in groups of 3. The first one is going to be you writing the equation, and then the 2 after that are substituting in to be able to find some information. So if you need any help with this, let me know.